My name is Mike Brookbanks, and I'm leading the research into trust, resilience, and cost in cross-border supply chains and the impact of Industry 4 technology. The research is primarily based on the Reducing Friction in International Trade programme, a collaboration between industry, academia, and the UK and Australian government. The goal was to determine how digital technology as a proof of concept implementation can reduce friction in international trade, with a focus on the small medium enterprise. In the early stages, work was completed to determine a common user journey and also the data model based on UK government, HMRC and food standards agencies' custom border requirements. The project or programme delivered a proof of value platform that integrated into HMRC systems. Within this work, we considered the end-to-end environment between the importer and the producer, considering the Australian Customs and Regulatory Authority requirements and the UK Food Standards, DEFRA and HMRC Customs and Duty requirements for movement of goods on import into the UK. So considered all the data requirements end-to-end required for the import of wine as a use case. This work and research built a body of work. We considered border operations and changes over the last 3 years, the process and the technology, but more importantly, the impact of policy. And we used case study research and considered that the programme through 3 lenses: trust and trust-based relationships, operational resilience, and cost and value. For each of these research areas, we have developed, or I have developed, a research objective with a number of questions which is used within the case study approach. Trust was built on a framework. It's a development of a model created within 2015 or published within 2015, but it builds and enhances on this model. And it considers all the elements of trust and how trust builds between parties. The findings and conclusions of the trust section determine that trust existed at different levels within this wine supply chain. There was a level of data duplication and manual data entry that introduces errors in the declarant's submissions, which are treated with distrust by the customs authorities. The current situation is there's limited supply chain visibility, and data asymmetry creates a financial cost and leads to reputational damage, especially with the importer. Blockchain, it was found that blockchain as a technology does not remove the requirement or change the importance of trust, but it does improve information sharing, reducing asymmetry, facilitating trust building processes and relationships. It removes some intermediaries, but it introduces others and therefore complicates the trust relationship. Clearly, as a result of this work, current policies requiring physical data records will need to be changed if the benefits of the technology are to be realized. The research in resilience area, we considered a broader view of technology. So it was, how does IoT technology and blockchain affect operational resilience? So how is operational resilience established today? What is the impact of recent changes at the customs border? How do groups of participants approach resilience? and what is the impact, or how does the digital technology, Industry 4, IoT, change the end-to-end operational resilience? Interviews with the supply chain participants ran from June to October 21. That gave us the insight of the latest changes resulting from EU exit and some view of the impact of COVID-19. Similarly, in the way for trust, the research has utilised a global supply chain resilience framework. It's based on established papers by Christopher and Peck and a development of that work. Considers risk management, supply chain engineering, so very much sort of planning and control side on the left hand of the page, and then focusing on collaboration, trust, agility, visibility, and adaptive response to disruption. So very much a reactive element on the right-hand side of this framework. In summary, operational resilience today is considered as a multi-thread approach, and there's no body of work that actually considers the complex supply chain, where there are three groups of participants. There's a core business supply chain, the freight forwarder and 3PL, the logistics companies, and the government and border operations. It was found that each party's approach to resilience is based on their business drivers, which is quite understandable, but that creates a discontinuity in the end-to-end resilience, where disruption of the border has an unclear and indeterminate ripple effect downstream. As I said, resilience within the supply chain is a balance of proactive and reactive approaches. So each group of participants has a different balance of resilience. But also, recent changes to the border have actually changed the end-to-end operational resilience, with the removal of custom-based systems and regression to paper-based systems or declarations. What we found, and the research found, was that blockchain and IoT technology improves resilience. It provides a common data store, high integrity, recording details of the goods. It improves information sharing and supply chain visibility, and as we found in the first paper, facilitates trust and collaborative relationships. But more importantly, it improves the integration and data sharing across government departments, and therefore opens the opportunity of improving operational agility and adaptability. In other words, improving government's responses to disruption. The third area of value and cost is developing. What comes from the resilience area is that disruption causes ripple effects that contribute to the cost of import and export. So the questions that really I wanted to consider and discuss today is, what is the current baseline for the import of goods and by process component? What are the ripple effects of disruption at the border? What is the static and dynamic cost today? And as you can see from the picture, I've drawn a graphic up of the impact of disruption. In my view, there is a static cost, which is the happy path of goods going through that core business supply chain. which with disruption, there is an adjusted cost. But also there's a dynamic cost, which is the impact of that disruption downstream, the ripple effects. Now, what I want to consider, and the work I want to consider, is how does Industry 4 technology change that static cost? Does it dampen the ripple effects from disruption and therefore change the dynamic cost and, in effect, the total cost of import? Through my work, there are some lessons learned from the RFIT programme. Cross-industry, academia and government collaboration does deliver when it considers the real problem. It can act as a nucleation of a broader programme, but there needs to be continual adaptation through the life of that programme. Communication, governance and continual engagement with the industry and the importers are key to success. These programmes do need sponsorship across government, and it needs to be communicated early. So incorrect or unclear communication leads to and has led to the wrong expectation across government. Having built the collaborative approach, the lessons learned need to be reiterated and reused within other programmes. So build on the use cases to develop a common approach. In other words, do not reinvent the wheel. Thank you very much.